Hi there, welcome back. And the next video in the series on this restoration of the Loewe-Opta Rheinperle 5717W. As I promised in the last video, this one deals with the completion and test of the restoration of the audio section. In other words, the preamp and the power stage. The audio section on this is very simple. It has once the audio comes in, whether it comes in from the pickup input or from the radio selection, you have audio from either FM or AM bands. It meets up and goes through some tone shaping and volume control. Now the tone shaping is quite interesting in that there are quite a few options here. We have various ways of preparing the signal before going into amplification. And basically these can be summarized as the bass control, less bass, more bass. This actually works in reverse. If you put it to the top clockwise, you get less bass, counterclockwise, more bass. The treble is normal treble, so clockwise, more treble, counterclockwise, less treble. Then we've got something called hi-fi. And the hi-fi has the effect of widening the sound stage. It gives it more high end and it really gives it quite a significant increase in the apparent quality of the sound. You've got SP, which is, I believe, Sprache, if that's the right word, speech. In other words, if you are listening to, say, shortwave, you put it on speech, it'll amplify or highlight the frequencies that deal with speech. You've got bass, which is self-explanatory. That increases, it gives it a bass boost. And that there is basically it. Now, to select the input, you would choose TA for pickup, and that'll bring the signal from the back input for the gramophone. Or you can have long wave, medium wave, short wave, or FM. Very straightforward. And as far as the actual restoration work is concerned, I will show you the schematic in a minute, but there isn't really that much to do here. There was the first capacitor here, which takes a signal from your input selector, whether you've selected pickup or radio. A couple of capacitors here, the one that, this is the capacitor, the one that feeds the grid of the output tube, the EL84, that was changed out. There's another one down here which takes a signal to one of the tone controls. I believe it's the treble. Another one down here. So basically we've swapped out. There's another one underneath here. 1, 2, 3, 4, 5. One at that end. 6 capacitors that actually were swapped out. Now you'll see one here that hasn't been swapped out yet, and that's because that's part of the radio circuit. I believe that's actually the AGC capacitor. But I'm doing this in a sequence and to make it more logical. Let me give you a closer inspection here. So we've got those down there, one underneath there, one at the top here. This one here was actually on the B plus line to the to the triode, if I'm not mistaken, the preamp triode. Now, I did a video in which I demonstrated how this assumption that I made about the quality of these capacitors can go very, very wrong. That capacitor there is the so-called the capacitor, or that capacitor, the one that isolates the preamp from the power amp grid. And I made an assumption that that was actually in good condition, and it wasn't, and I've just done a short video showing you how badly wrong that can go. There's a link above if you haven't seen it. And the reason I made that assumption is because those capacitors were very similar to those guys down there. Now that's all in the tone shaping circuit. It's actually on the feedback circuit from the output, which we'll see in the schematic in a minute. And those capacitors were tested with the capacitance leakage tester and with the capacitance meter, and those things were like new. They were perfect. And my assumption that the ones in the power amp stage were good as well was because they looked the same. They were the same brand. However, the difference is that these were low value voltage capacitors. These are 125 volts. And the guys down there were 400 volt capacitors. And the fact that those down there had been subjected to high voltages obviously created the leaks over the years, whereas the ones in the tone circuit were perfectly new, as it were. So again, very careful. Just a little bit of extra work. These were actually quite a bastard to get out, but it makes it all worthwhile. I did swap out one resistor so far. That one there, that's the cathode resistor for the EL84. The original one was actually reading fine, but it was showing signs of actually sort of basically falling apart. And I decided to swap it out as a precaution. But basically this the whole thing is ready for a test to see how the audio sounds. I've wired temporarily a small wire in there to make it easier to feed a signal, an audio signal into there. I don't actually have one of those DIN plugs. There's quite a few DIN plugs lying around, but I couldn't find the exact one that is used there. So we'll be ready to do that test in a minute. But let me just show you the schematic and tell you what we've got so far. Here's our schematic, and as you can see, quite a bit of progress has been made. The verifications or checks and corrections and changes that I've done since the last video have been put in orange and red. And the reason is just to give us an idea of what has changed as opposed to seeing the whole thing. As we can see here, we've got our gramophone input over here. And that gramophone input obviously is mono because these two are wired together. And these two actually come back through to here to the tape recorder. It can be used as an input or as an output. If you feed a signal through here, it goes in here, up there, and into that switch. If you feed just a gramophone, it goes in here, up to that switch. So effectively, you can use this selection as either gramophone input or tape input. This one here is the record line. If it comes back from there, from there, from there. In other words, this switch selects whether you're going to hear radio or pickup. This is actually the TA switch. Whatever you select there goes through that capacitor, which was changed out, to there. And from there, it goes up or down to the record pin of that the tape recorder socket. If it goes up, it comes up here, and as you can see, it goes to the top of the volume control pot. That top of the volume control pot sees the entire audio signal. There is a capacitor with a switch here, and what that's doing is that it's actually either shorting out top end or allowing top end, depending on how that switch is activated. That K I believe is, what is K? K is the hi-fi sound, okay? And what it does is it will affect the high end because only treble frequencies, high frequencies, really flow comfortably through a capacitor. There is actually this is not the bottom of the pot or the center tap. There's a separate tapping off that pot, which is used in the tone shaping circuit. And this is to create a pseudo loudness effect. I've covered that in a few of the restorations I've done before. A lot of these older German radios had that. It really does affect the sound at low volumes. Then you've got your bottom of the volume control, which is not straight to ground. There's a 470 ohm resistor here. And the reason for that is you're actually adding or subtracting at this point. It's actually negative feedback, if I'm not mistaken, coming through this capacitor and resistor network, which comes through this capacitor resistor network, which involves two switches here. Now those are D and G. G is speech, and G, what is G? It's speech, that's G. What is D? D is bass. Okay, so this signal comes from the speaker. There's the speaker output. It goes through another winding, and it goes down here. There is a J switch here. There's a resistor and a J switch. J is hi-fi as well. So what happens is, if you leave this open, it goes straight through. If you close it, if you select hi-fi, it will make the resistance between that point and this capacitor down here smaller. In other words, it'll change the roll-off of the frequency passband. Basically, it's just determining how much of the high frequencies or low frequencies comes back to act as negative feedback. So what I've found was these capacitors were all fine. I found a couple of mistakes here. I found some labeling was wrong on this switch. That's it says A, it's actually B2 and B3. That capacitor was swapped out. That's a bigger one, which was not the same type as these that I left in. So that was swapped out. This resistor says 100K on the schematic. It's actually 10K in there, and it looks original. So I presume there's an error in the schematic. And that happens quite often with these old circuits. And again, I had the same correction here. This says 330. There's actually a 330K resistor in there, and it's measuring perfectly fine. So I presume there's an error in the schematic and left the resistor in there. So that was checked in great detail. And then our signal comes out of the wiper of the volume control down here through this capacitor, which I changed, into the grid of this triode, which is a part of the EABC80. There's a 10 mega ohm grid leak to ground. This is to add to the, or allow for the biasing of this triode, because this cathode is connected to ground. So you need a very, very high resistor here to allow this thing to bias. And then it does its job and amplifies the signal, which then goes through there. This capacitor here is to remove some RF from the line, so you don't have any very high frequencies going through, because now you're going into the audio circuit and audio amplification circuit. We have a capacitor and a pot to ground. Now this capacitor and this pot would change the cutoff of high frequencies to ground. So this is the treble control. It says 500K. I actually measured 2.2 meg. Now this again could be an error in the schematic or not, but it doesn't really make much difference because it is a log pot and it is a variable resistor wiring. So effectively you just turn it clockwise, or clockwise as much, clockwise or counterclockwise, as much as you want, and it either increases or decreases. The fact that it'll increase beyond 500K doesn't make that much difference. You just stop when you like the sound. This is that capacitor, which I learned at my expense that I had to change always, as opposed to trusting it ever, right? Signal then goes in here. This is another one of those pre-selected tone functions. I'm not sure which one. F, it'll be bass or treble. And then it goes in here, 1 meg grid leak to ground through a 1K grid stopper to the grid of the EL84. That EL84 has a 150 ohm bias resistor, cathode resistor. This is the one I swapped out. Although it read fine, it looked like it was almost at the end of its tether, so I replaced that. This resistor is very important if you want this thing to bias properly, so you don't want this thing to blow up. The cathode bypass capacitor was changed out as well. It was an electrolytic, didn't look too good, and it had a huge ESR, like 30 ohms. This one was dead. Then signal goes up here into the output transformer, and the rest we have seen. So this circuit is ready for testing, the audio circuit. And to test the audio circuit, what I'm going to do is I'm going to feed a tone from the signal generator into the gramophone input. I'm going to select gramophone so we don't hear radio. I don't have the tubes fitted in the radio anyway. The only two tubes I have fitted are the preamp tube and the power amp tube. And then I'll connect the oscilloscope to the output, and I'll be using a dummy load here so we don't have to hear the tone, and we'll be able to see the result on the scope. One thing to bear in mind here is you should be very careful that the ground of the scope goes to the right point here, because if you get it the wrong way around, because your ground on your pickup input is from the signal generator and the signal generator's ground is connected through mains earth to the oscilloscope ground, you could create a short. So you have to be very careful with that. And we'll see what the result is. But so far, so good. I can tell you already that it works pretty well. I'm not getting as much output power, clean power, as I thought I would. But we'll see that in a minute. Right, let's see the setup. Signal generators producing a 600 Hertz signal, 200 millivolts RMS, could be 100, could be 3. I'm leaving it at 200 millivolts RMS. Coming out here, activate that. It's going into the pickup input, ground and pickup input. I select pickup here. I've got the speaker outputs going through these cables going into here. I've selected 4 ohms here because I've measured the actual speaker and it reads about 4.2 ohms. These speakers in these radios used to be about 5 or 5.6 ohms, but on this one it reads 4, so I've chosen 4 ohms. I could have chosen 8. I've got dummy load as opposed to speaker, and I've got the oscilloscope output going up to channel 1 on the scope. And I've just switched on the set. I've got the light dimmer on 1 bulb, so maximum restriction just in case. And we can really see something. The volume was on max. You shouldn't start this with the volume on max, but hey. This is the result. Very low volume so far. Let's change the range here. And we're going up, 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 up. Everything's clean. Change the range again. That's to 1 volt per division. And I've got it on max volume. And it's giving me, with the 200 millivolts input signal, it's giving me 1 volt RMS, 1.09. If I mess with the tone controls, here's the bass control. Now this is a 600 Hertz tone, so it does have some effect on bass. But if I bring that down to 300 Hertz, the effect on the tone is obviously more noticeable. If I take this up back to 600 and leave the bass on max, and now I'm going to go to the treble control. Let's drop that. Treble control, I start getting the peak, and what we've noticed here is we've actually reached the where it starts to clip, and it's clipping on both sides. If you can see the bottom of the waveform starting to bend, and so is the top. So this thing's actually pretty well biased. If I bring it to where it's, well, there, actually what I'll do is I'm going to leave it on max, and I'm going to drop the amplitude on the signal generator till it stops clipping. There it is. That's a clean sine wave, pretty clean. A little bit of warping, but that's 130 millivolts RMS. So we need 130 millivolts RMS to get maximum volume, clean volume, out of the power amplifier section. And that power is 2.5, it's about 2.5 volts. So what does that come to? It's about 1.5 watts. And it isn't much. I always expect a bit more, and I always get less than I expected. And that's on 4 ohms. If I up it to 8 ohms, it's already clipping. So I'm not quite sure what the speaker is supposed to be, but on 4 ohms, that's what we're getting, clean signal. 2.47, 2.5 volts RMS. Right, now here, if I reduce the treble, that's the effect. If I increase the frequency to, let's call it 1 kilohertz, then the effect of the treble cut is more pronounced, because 1 kilohertz is more in the treble territory. And let's see what happens when I push, say, hi-fi. Nothing there. So hi-fi doesn't affect high frequency. SP, speech, drops the treble, as you can see. Bass should have no effect on 1 kilohertz. Now let's take this down to 300 hertz again. Get a clean wave. Now, if I push hi-fi, it's affecting it. It's actually affecting it in a way contrary to what I expected. But because I can't see the whole bandpass frequency response, I'm not sure exactly what it's dropping, but it's certainly dropping part of this. Speech, whoa, that drops a lot. On 300 hertz, it drops a lot. The fact of the matter is, our power amplifier is working fine. It's actually producing a pretty clean wave, and although the power level is slightly lower, there's a 2 volts RMS clean sine wave, and a little bit of warping. I can see a little bit of warping on there, so there's obviously some harmonics there already. Some of these harmonics will be the pleasant sounds that we talk about when we talk about tube audio, tube radio, and tube amplifiers. But there is one more thing I've just remembered. Yep, by the way, I'm going on holiday tomorrow, so the fact that I'm forgetting things means I'm needing this holiday. One thing I've just remembered is I've still got the maximum limit on there. So let's see what happens if I give it more voltage. It's cleaning up. Yep. Let me bypass the dimmer altogether. Voila. We've got 2.4 volts. Let's see where we go to. There's maximum volume. And I've got 3.11. Let's call that 3 volts. Just drop it slightly. That's pretty clean. That's 3 volts RMS. So power is voltage squared over resistance. So voltage squared over resistance is 9. 3 times 3 is 9 divided by 4. So we've got, what, 2¼ watts. Again, I expected a bit more from an EL84, but it's all got to do with the B plus value that you have here, and with the biasing and so on. So pretty good signal from the recapping that I've done. I also am not sure just how strong that EL84 is, and even the preamp tube, but this is what we have at the moment. And needless to say, I'm quite happy with the result. I don't see any noise. I've cleaned the pots. You can see that there is no spiking, no crackling going on there. I've obviously done that turn on a speaker. There's no crackling. There's no crackling on selecting of the tone shaping switches. So it's looking pretty good so far. Now the next stage is obviously getting into the radio, and I'll probably do that when I come back. So I'll be doing the AM section first, and then I will finalize with the FM section, which I'm almost certain there's something wrong with the tube that's in there, because that burnt out resistor we saw that's supplying B plus to the FM front end certainly raises a few alarm bells. Anyway, hope you enjoyed that. Thanks for watching. Like, subscribe, and all that jazz, and I will see you back soon. Bye for now.